Hello, welcome to the New Stack Makers, a podcast where we talk about at-scale application development, deployment, and management. This episode of the New Stack Makers is brought to you by Portworx. Portworx is the leading provider of persistent storage for containers and is used in production by healthcare, global manufacturing, and telecom members of the Fortune Global 500 and other great companies. Learn about Portworx solutions for Kubernetes storage, DCOS storage, and more at portworx.com. Hey, it's Alex Williams, the New Stack here at KubeCon CloudNativeCon in Seattle, Washington. It's day 2, and we have with us some guests who are going to discuss a little bit about the holiday season, I think, and how you prepare for it. Joining us is James Webb of T-Mobile. Hey, James, how are you?
Good, how are you doing?
And we have Venkat Ramakrishnan, VP of Engineering at Portworx. Thank you very much.
Thank you.
And Joe Jackson, our managing editor and co-host today.
Hello.
So, James, why don't you tell us a little bit about what you talked about today in your discussion for people who weren't there? I know it was about how you prepare for the retail season. Maybe you could give us a summary of how you organized what you're talking about.
This is a talk at the KubeCon 2018.
So the talk was just basically we've been running large container platforms at T-Mobile for about 3 years now. So what we found is that one of the biggest demand times, obviously, is two things really. One, it's when new phones come out from some of our partner suppliers in the October timeframe, and then weekends into the holiday season. So the demand on our systems goes up about threefold. So we size our systems and scale up to meet that demand over the course of the winter. So with our Kubernetes offering, we knew it was going to be a new offering. We weren't sure what demand was going to be. We didn't know how much load would be on the system. So we just kind of, during the talk, we talked through, actually we came to the conclusion when I wrote the abstract for the talk, we thought we'd have a lot more demand on the system than we did. So that was kind of a lesson learned is, planning-wise, we weren't quite ready yet. We weren't quite ready we had the platform ready, our customers weren't quite ready to adopt yet. But a lot of our customers were running on our other cloud-native platforms, and we did on those, we scaled appropriately for the holiday season. What that looks like is, and it's a great thing for the customers on the platform, is instead of them having to go out and request new infrastructure and install it from the ground up, they just spin up more containers. So the talk just kind of covered like our background in Cloud Foundry and Kubernetes, and how we're trying to make our Kubernetes environment look like our Cloud Foundry environment, and that's kind of the model for handling load, both normal every day and holiday.
Terrific. And so you're running this Kubernetes deployment in-house?
We are.
All right.
We're crazy, I know. That's what everyone tells us.
Nice. So what was the choice with, if we could step back a few years, what was the choice? What was the pain point that led you to do Kubernetes in the first place?
So the Kubernetes is a 2018 initiative. What drove us to containers in the first place was just simply that in order to get code from the development environment into production took up to 6 months and 72 steps. So we knew that was a problem. The IT department was not able to move as agilely as our business was asking us to. They would often really press for solutions, and in some cases even look outside for solutions to be provided. So we had to go back and start from scratch and figure out how are other companies delivering very quickly. And one of the things that we found was is not just DevOps, but having platforms that enable DevOps teams to actually deliver same day changes, planned deployments 24/7, smaller changes instead of large changes once every 4 months. It's small changes every day. What were the platforms that enabled that? And Cloud Foundry and Kubernetes were the two that seemed to really stand out. We feel like Kubernetes is kind of won the scheduling war in terms of Docker containers, so that's why we chose that, and now it's just a matter of how do we bring it to the enterprise.
Nice. And so the applications that they have to, I mean, both Cloud Foundry and Kubernetes, it's good for scalability, as you point out, Kubernetes in particular, but did you have to change the way you were developing applications?
We did, and that it's been a big change for our development community. So they're still trying to figure out how to use these new tools. We have a lot of help. Where we bring in, it's one of those things we bring in some consultants from industry to help us, refactor our tools and refactor our apps so that they fit on these platforms a lot better. But it's interesting because there's resistance at first, but then once they're on the platform, they love it. So we remove a lot of operational overhead from them. Instead of them having to maintain infrastructure, they get to write code. So that's the real key of the platform, is that developers get to develop instead of do a bunch of other things, right, that they used to have.
Nice. So the developers are using Cloud Foundry to build and maintain the apps, and then you're running them on Kubernetes.
No, Cloud Foundry is a separate platform, but essentially not everything runs well in Cloud Foundry. So we built Kubernetes to cover the gap of containers that don't run well in Cloud Foundry. And we know there's a lot of them out there. It's databases, stateful applications, vendor-supplied containers, so things that are non-native to Cloud Foundry. So it's our current Cloud Foundry implementations, not even a small set of our total application portfolio. So
sure.
we believe that Kubernetes is going to surpass our Cloud Foundry implementation over the next year and a half. One of the key components for Kubernetes offers is the ability to persist data in our containers. And it's tricky with containers. It's tricky because you're having to present storage through several abstraction layers.
Right.
You're having to manage it. You're having to manage it, and we really are looking to put critical data into our Kubernetes environments. So we looked for a partner that would provide us a stable, performant environment, and Portworx checked all those boxes. So we are very happy to have that deployed in our systems.
So maybe you can tell us about the overall architecture and how Portworx fits into that. So I'm curious on how you think about that substrate.
Yeah. So we followed somewhat of a cloud model when we did our infrastructure deployments on-prem, where we would create 3 AZs for what we're calling a region. We used to call it a pod, but then pod created too many naming conflicts with Kubernetes. So the idea is that an individual rack is a shared nothing rack. It shares no infrastructure with the infrastructure with the other AZs. So that's great for Cloud Foundry, where things are stateless and everything's replicated between AZs at an application layer. We wanted to be able to provide to our Kubernetes customers a data layer where they didn't have to worry about replication, where we could give them, we could say, you come to the platform, make a storage claim, and we will give you a single AZ volume depending on your data needs, or we'll give you a replicated volume depending on your data needs. Our initial pass at providing Kubernetes environments for our customers is we're trying to give them more curated environments where, again, the efficiency is them developing, not them worrying about whether or not their data is safe. So that's the idea with giving them an environment where they can just onboard to the environment, request space, and they know that it's replicated and that will support them.
All right, so when you say customers, you don't mean T-Mobile's end customers, you mean, or you do?
Yeah, so we T-Mobile, and I know other companies do this too, we have big C customers and little C customers. Big C customers are customers with phones, little C customers are internal IT customers, right? So
okay.
we are, when we say customer, we mean internal IT customers.
Gotcha.
In most of those cases.
Gotcha. Terrific. So the storage problem is, of course, Kubernetes is moving containers around to the best suited, and so, but this is problematic because the storage for the application has to be at the same place in terms of, I guess, an IP number or something.
Yep.
And so the Portworx handles this translation, I take it?
You can speak to that better than me.
So, just to step back a little bit, Portworx is built for use cases like what James described about is how do you build cloud-native data services on any infrastructure? It could be your own data center where you're building multi-AZ services, or you're running and onboarding your apps on a public cloud, right? So what Portworx does, at a very fundamental level, it enables deploying highly available services on your container orchestrator. Now, Kubernetes being the most dominant now, but we have supported multiple different orchestrators in our history, right? But it enables you to deliver these highly available services on top of Kubernetes, and provides the data storage layer for Kubernetes. So it enables you, like for example, a container gets scheduled, a pod gets scheduled in one of the nodes, and for some reason the node goes down, there's a network partition happens, then the scheduler would reschedule that node. For whatever reason the scheduler decides that that pod has to go to a different node, and Portworx automatically manages the availability of the data for that pod in any other node that's in the Kubernetes cluster. It's highly transparent to the user, for the operators of the infrastructure. At the same time, we provided a level of abstraction for the customers of someone like James, so they can actually specify the kind of characteristics they want from the storage volume that's getting provisioned.
So does the storage kind of carry, do you carry that with the container, that persistence then? Is that how it works?
So the storage for that container is made available through Portworx's data storage layer, right? But the data itself can be available in any of the nodes that are part of that volume quorum, or it can be remotely available as well.
So it's called, the data can be called then?
Yeah, the data can be called, yes.
Right, and so maybe you could tell us a little bit about the architecture underlying that.
Absolutely, yeah. So at the very fundamental level, Portworx is a distributed block storage layer. Right, it's distributed blocks, and it's a distributed control plane as well, where you don't have any centralized name node management or metadata management. The metadata and the data is highly distributed across the cluster. We support things like container granular volumes. So each container can be given a volume, and you can offer other volume and data services like snapshots, encryption, replication, and even backing up to a cloud or migrating data across clouds per volume per container. So that's the underlying fundamental architecture that's built from the ground up with like as a distributed block store, a distributed control plane, and an autonomous policy engine, and it's also cloud and application aware.
So how does that use case then apply? How does it apply for T-Mobile? How are you using the?
So the first use case is just like make the data available to a local cluster, right? So that's sort of table stakes, right? It's like we want to have a reliable volume service available for customers to use, and that's coming from a Unix background, right? Like managing your storage, the tools to manage your storage are incredibly important. So Portworx has an impressive suite of services that really help you control what you offer your customers, how it's managed, and it gives you good visibility behind the scenes into what it's doing. On top of so that's table stakes, right? It's like I want storage for this single cluster. Next is I want to deploy my application to 3 clusters. I want to keep data in sync across 3 clusters. So how do I do that? There's one way to do that is put the burden on the application team at the application layer to replicate data. Some things do that natively, no problem. They can do that. We're not going to block that. Other customers will come and say, I don't want to worry about that. I don't want to worry about the mechanism for that. I just want it to happen. So they can request that, and we can provide that service initially somewhat managed for them, and ultimately the idea is we do it in a self-service fashion, right? We let them manage where their data is and where they're running their workloads.
Perfect. Hey, let's talk surge traffic. I remember last year at Container Days, an e-commerce site, I think it was a shoe company, they were talking about how they'd run these promotions, and you'd have to get to the site at 12 o'clock at a certain time. And then, of course, their traffic spikes by 1,200% or something like that. But your situation's more seasonal. How do you, and you had mentioned that sometimes you get the anticipated traffic, sometimes you don't. Can you talk a bit about your scaling mechanisms? And
so most of the platform ones provide an auto-scaling mechanism. The problem is that most auto-scaling mechanisms work on a 1 minute interval. So what we found is that that cannot keep up with the demand and load, right? It's like phones go on sale at midnight. At midnight, load jumps within 2 or 3 minutes by 10x. So what our teams do, and what the platforms have allowed us to do now, is platform teams will proactively go in, scale up their applications to what they think they need, 3 or 4x of what their normal deployment is, and usually that's enough buffer so that on that initial bump, if they need additional resources auto-scheduled, it can pick that up. But usually we cover what the initial hockey stick puts on the pressure that puts on the infrastructure. And what we found now is that most of that is where that's a problem still is in legacy infrastructure components that have not moved onto the platform, right? We still hit that problem, but it's usually on platform, we're usually able to deal with it. Off platform, right, it takes a little more work. So.
Nice. Terrific. So now Kubernetes is still a relatively new technology. There must have been some challenges in terms of putting it into production. Maybe
it's both challenges on our side and on our application team side. It's a new technology. We're not familiar with it as much as we should be. We're getting a lot of help again from partners that have a lot more experience in the field. We are a big Pivotal customer. We deployed Pivotal container services. They actually are very helpful in getting our workloads up and running. So that's kind of one of our initial, rather than have large teams that back-end engineer to figure out how to deploy the clusters, we just get the clusters on demand from them, and we can focus on above the waterline value problems, which is how do we get our apps into production.
So Venkat, what are some of the services that you provide T-Mobile, for example? James was mentioning these services in particular that come with the Portworx platform, the Portworx technology.
Yeah, I mean, so some of the services that James's team uses, at a storage services level, like Portworx offers like a distributed block, distributed file, distributed object, right? And and how we enable that is an application spec in Kubernetes can typically come and specify what kind of a data service that they need from Portworx, because Portworx volumes are natively supported in Kubernetes distros today that ship, right? So they can specify what kind of service they need, and when that app gets scheduled, it can programmatically query that service from the Portworx data storage layer, right? And we enable creating the service endpoint, like which would be a volume or a file mount, or a REST endpoint, and then make it available for that application in the node that the app gets scheduled. Right, and from that moment on, there is a relationship that gets established between an app and the data and the volume for that app. And then Portworx keeps track of where that pod gets scheduled and an app gets scheduled again, how to make the data available, and automates all of that underneath. So for a large-scale cluster operator, they don't need to worry about how do I move my data, how do I migrate my data, how do I ensure that the infrastructure they have is resilient to failures in nodes or across the racks and all that, and Portworx enables that. And Portworx also does cross availability zone replication. So we are topology aware. So when you deploy Portworx on multiple racks, and if once we discover the topology, then we can place the data across different availability zones. So we make the entire infrastructure tolerant to any failure in a single rack or a single data center, right? So all of that services kind of gets wrapped under a very simple interface to consume, and it's a very programmatic interface that's declarative. Like someone can come and in real human readable language can specify what kind of characteristics they want from their underlying infrastructure, and with help of Kubernetes, Portworx makes it happen for them.
How does Portworx itself, the software itself, avoid the single point of failure problem? It sounds like you guys are running a distributed.
It's a great question. So Portworx again is built based on it's a distributed control plane. We do not have a name node concept, so there is no single node or point of control where failure in that actually gets the cluster down, right? And then we are we use these distributed protocols like gossip and gRPC for for communication across the cluster. We gossip across the cluster nodes to make sure that we understand the cluster membership. We use Raft, which is another cluster quorum protocol. So combining all this together, everything wrapped under a distributed control plane, helps us build a no single point of failure kind of distributed cluster model.
Isn't etcd very similar to Raft?
etcd is one of the Raft-based
Yes.
servers.
Yeah,
like you have
right.
Consul, etcd, and
Right.
you have a whole bunch of other things.
So you use a Raft-based?
We use a Raft-based, a Raft-inspired.
Raft is of your own that you...
We have taken some, we have made some modifications to whatever is freely available, and we have kind of fine-tuned it for our own use case. Yeah.
Now, James, what are you actually using to hold the data? Are you doing NoSQL? Are you doing SQL? Are you doing flat files? Or
It's up to the application teams. It just depends on what they need. For messaging queues, some teams are using Rabbit. Teams that just need like simple data services. They deploy a simple database. They're very familiar. We have a lot more familiarity with ACID compliant databases than we do NoSQL stuff at this time. But teams are starting to investigate that. So right now it's kind of what the application team brings. Longer term, we're looking to offer managed data services where we'll offer a suite of basically operator based, where you need a data service. You can just hit a service broker and it'll spin up an instance for you and provide that data, right? And it's back to the same thing. This is again where the storage is going to be very important. Is when we start, right now most data on the platform is just simply is caching data, right? If something happened, we can recreate that data by going to the source of record, right? But we're looking to promote source of record data to the platform. So we're going to do that cautiously, but we're trying to build the platform to be resilient enough to do that, right?
So you're looking to minimize the cache layer then?
We're looking. So in that case, there would still be a caching layer. At this point, we're looking to start pulling data out of these large old monolith applications, right, and distribute it where it's closer to the application and built in a more cloud native way instead of a single database that's running in an active passive failover mode, right?
So in any case, when we're talking through these approaches, how does this compare to your older the older ways that you used to do this?
Night and day, right? We are managing resources within a platform instead of managing, instead of managing VMs and VM clusters, right? Instead of building a VM and then installing a bunch of agents on it, and and then handing it off to this team for monitoring, and handing it off to this team for backups, and handing it off to this team for something else, and then handing it to the app team, and then they install the application, right? The way we were modeled was. Those are all disparate groups. That there's a lot of lag between each of those services. So it could take you weeks to get a VM, right? You'd ask for a VM, it could take you weeks. We've had customers that we can reach out to us, give us their requirements. We onboard them that same day. They can push an application to production that same day, right? Because we build in all the resiliency is already there, all the load balancing is already there. There's an SSL cert that's already there if they're using HTTPS, right? So this has had a huge benefit for our application development teams, and not just development teams, but front end, the actually operations teams as well, because they used to have to worry about that as well. Now they can actually work closely with their development teams and focus on functionality, not on infrastructure maintenance.
So focus on the business logic.
Exactly. Yep.
It's interesting. When you think about this, how do you think about your team composition and how you develop your teams?
It's changing, and that we had a little comment in the talk where when we were first ramping up our team, it was hard to find. We opened some job recs and no one was. We were looking for very specific experience with Cloud Foundry or Kubernetes, and those folks very few people applied, and it's what we've come to realize is that the people that have those exact skill sets are very valued by their company and that aren't really usually looking at this time. So we turned internal and started hiring some of the folks on our internal teams, whether it be from our Unix team, our Windows team, our storage team, right? People that are interested in where we were going, and we looked more for aptitude and attitude versus did they have a specific skill, with the assumption that we could train them up or they would train themselves, and that's happened, right? We have a couple of guys who will come in and come in the morning and then go home and come back in the morning and you can tell that they were at their queue very late, because they were just looking to solve a problem. And I don't want people working, outrageous hours. It's nice to see that somebody sticks with the problem until it's solved. But we've got a great team, and I couldn't be happier. So.
That's great. So, when you're thinking about customers out there like T-Mobile, do you see a lot of changes in how they're thinking about their teams as they start to work with you?
Yeah, absolutely. I think one of the things I've seen is how there's a very good separation of kind of crystallizing the responsibilities. There's a team that manages infrastructure, that provides the infrastructure services that can onboard different apps, and then you'll see a lot of teams where the developers are consumers of that infrastructure. There could be internal customers, internal developers, or people who are actually developing apps that are either for internal use, or they're kind of using that infrastructure to production test their apps and then roll it out into the cloud for running in production, right? So you see that there's a pretty good separation of responsibility that's starting to come up, and for someone like Portworx, and especially in the Kubernetes community, we are talking to almost two sets of audiences. There are people who operate the infrastructure, and they have a specific set of requirements. They want to have, they have specific requirements on how they build their infrastructure, how they manage it, what kind of monitoring requirements they have, and the compliance and regulatory things that needs to be taken care of. And then the developer community that are consumers of that infrastructure, and what they want, how much power they want from their underlying data services, right? And how do so what Portworx was built for from the ground up was to be able to service both of these audience,
right?
And that's how we are seeing how the community is evolving.
So, and those audiences are converging, right?
Exactly.
With the platforms now, we are closer than ever with our customers, right? And we have to be, because they're, part of it's just because we're learning together, right? How to operate in the cloud native world. But when I had my Unix past, a lot of times you would just build servers, hand them off, and never hear from your customer again, right? Until they need you had to tell them you were patching their server. That's just not the case anymore. It's a much more interactive community. We like to bring our customers together, and what we found is our customers have actually gotten to the point now where we have a Cloud Foundry Slack channel and a Kubernetes Slack channel, and often a customer will post a question and another customer will respond, right? And that's fantastic behavior. It's really
I think it's very community. I agree with you.
It's not only is it great to work with your peers, but it's also great because we don't have to answer every question. We're not on the right. It's fantastic.
I agree with what you just said. Is I think the community of we love Slack, right? I mean the community of how the other developers are working with each other, and how they are helping build each other's infrastructure and the apps they need is great, right? The other thing is never before. I think the app developers and the developers have a lot more control over the infrastructure, right? So it's becoming a much more of a team effort, as opposed to I'm filing a ticket and then it gets serviced God knows when, and then they come back, or someone who deploys infrastructure and who consumes it, they never have an interaction for a long time. But instead things move very fast in an agile manner, dynamically tuned, and that actually also helps build and test and run apps in production much faster than before, and that's what the new workflows really enable.
So you run Kubernetes internally there on-prem, and what do you see? You've come a long way, all right, in terms of your infrastructure. What are some of your goals for next year? Are you starting to think through what would you like to improve upon? What do you want to build upon?
It's adoption, right? Is now that we've built this platform, right? We're hoping that we're going to get customers coming, and we know we will, right? So that's it's the way that it feels like technology adoption at T-Mobile happens. You either kind of flatline and then drop off as people move on to new technologies, or you hockey stick, right? I feel like we're just right at the beginning of the curve change in the hockey stick. So it's going to be on board. The next thing is looking at extending Kubernetes with service mesh, Istio Envoy, looking at the operator landscape is just starting to emerge. Federation of clusters where an app team can just push an app and it runs in multiple clusters automatically without them having to do anything. So it's just going to be keeping up. The technology's changing so fast. It feels like just keeping up with it's a job all by itself, much less translating what we learn into our on-prem offering, and then also being able to help customers understand what we're pushing there. there. But again, that's where we're looking at our customers to kind of help us, okay, we enabled these features, you help us figure out how to use them, right, and figure out where the gaps are in what we're providing.
Are there any internal projects? You mentioned the operators. Are there any projects going on that you might consider open sourcing one day?
Yeah, so we also have a public cloud team, and they also have a Kubernetes offering, and it just depends on, again, back to internal customers. Some customers want to be closer to the internet itself, and some of us want to be back office and facing internal call centers and retail stores and that kind of thing. So they are looking at building some abstraction layers, right? So I think that's been a theme of the conference here actually is should app devs need to use kubectl, or should there be an abstraction plane above that? And they're trying to solve that problem, right? That sounds like a lot of companies are doing their own internal development and doing or looking to the community to help solve those problems. So our internal team is looking at building a product and open sourcing it. We're looking at Knative to solve that problem, but T-Mobile's changed in the past few years where 5 years ago it felt like you mentioned open source and that you kind of not got ignored, but we weren't ready for it yet. Leadership realizes now the value of not just in terms of the value we get from the open source community, but the value we get from in terms of recruiting, visibility in the community. We get a lot more than we put in. So that's changed, and now we actively contribute. So it's
nice. We're certainly hearing a lot more about managed Kubernetes environments for developers. Yep. You don't want to give them the keys to the hot rod without some guardrails in place.
Yeah. In a way, it's a step back, because now they have access to all these infrastructure primitives again, and it's not that we don't trust them. It's just that it just creates more ability for them to do things in a non-standard way. This team might do something differently from this team, right? We're trying to get folks to to converge on a very similar set of patterns, and the easiest way to do that is give them a common abstraction layer, right, to deploy their apps.
So just in conclusion, what was the hot topic that you guys were hearing here? What were some of the conversations that you had with people that you remember and that will kind of go with you?
Actually, what we just talked about, right? I think an abstraction layer is going to be a big focus for not just us, but for a lot of teams in the next year. Operators is another big thing. Knative, which is kind of back to the abstraction layer, is another really big thing. So it's a lot of really interesting projects.
Yeah. I mean, as what James said, the abstraction layers is pretty, but like ability to kind of abstract different infrastructure, different cloud infrastructures, and kind of make multi-cloud a consumable resource. And how do you orchestrate apps and move apps between different cloud infrastructures seamlessly, right? I think it's becoming, I heard that a lot here, right? I mean, when we were describing, what we just launched, which is PX Motion, which is a multi-cloud, data orchestration, right? When we were describing that to customers, our customers have heard about it, who came and told us that, hey, tell me more about it. And the moment we would say, we enable you to move or, run apps in 2 different cloud infrastructures and to be able to move data across data centers, they're like, exactly what I was looking for. And I think with Kubernetes is much more easier, and tell me more about how I can make it more programmable, how I can use it in my infrastructure. So just from that standpoint, I think this KubeCon, just talking to everybody and the customers and the partners here, I think hybrid multi-cloud is a reality, and Kubernetes is accelerating it, right? And that's what I take away for me from this KubeCon.
All right.
Yeah, actually, this is pretty amazing. the KubeCon here, it's like attendance is amazing, enthusiasm is amazing. The just the amount of companies that are attacking all these edge case problems, and really, like, you go and all of them have value. You see the problem that they're trying to solve, and it's going to be very interesting to see how it all shakes out over the next year. It's like it's a brand new ecosystem, right?
Well, it's keeping us all busy, isn't it?
It is.
Yeah. Well, thank you very much for your time, James. Good luck with the holiday season. It's here. We're right in the middle of it. How's it going?
We're pretty much through the biggest days are kind of almost behind us. We have one or two more weekends, but it's Black Friday, Cyber Monday, and then back in October when.
And Venkat, thank you for joining us.
Yeah,
I appreciate your time. And Joe, another good interview. So appreciate it, and we'll talk to you soon.
Exciting times. Thank you.
This episode of the New Stack Makers is brought to you by Portworx. Portworx is the leading provider of persistent storage for containers and is used in production by healthcare, global manufacturing, and telecom members of the Fortune Global 500 and other great companies. Learn about Portworx solutions for Kubernetes storage, DCOS storage, and more at portworx.com. Listen to more episodes of the New Stack Makers at thenewstack.io/podcast. Please rate and review us on iTunes, like us on YouTube, and follow us on SoundCloud. Thanks for listening, and see you next time.